Welcome back. This is more information for Unit 5. We're looking at multiple regression, and I have another example for you. This particular example will involve multiple steps, where we'll start off with step 1 and use one set of variables to predict an outcome, and then we'll go to step 2 and have an additional set of variables that will get added to the equation, an additional set of predictors. This particular study is one I did several years ago, where I had people who were married completing a questionnaire on the internet about their experiences when they had conflict in their relationship. And specifically, we're going to look at types of emotion people might experience in a relationship when they have conflict with a partner. Go over some. We have one type of emotion. Sometimes I call this hard emotion or anger. It's a type of emotion that often increases negative communication. When people get angry, that might escalate the conflict, and they might use negative communication where they criticize each other or get defensive when they listen to each other. That might decrease positive communication. When people get angry, they might be less likely to listen to their partner, or they might be less likely to express their viewpoints in a constructive way that makes it easy for their partner to hear and listen and understand. When people experience hard emotion and they feel angry, they're likely to be perceived as being threatening. And we can describe hard emotion or anger as having a self-focused goal. That is, when you feel angry, it's because you have some objective that you're trying to accomplish, and oftentimes you perceive that someone else is blocking your ability to obtain that objective. And so there's something about oneself. You have a goal for oneself you're trying to achieve, and you feel like that goal is being thwarted, and that can lead to feelings of anger. So we can talk about hard emotion or anger as having self-focused goals. We might contrast that with soft emotion, which can be feeling sad or hurt or concerned or disappointed would be types of soft emotion. So both anger and sadness, and there's hard emotion and soft emotion, these are both emotions that people might experience in a relationship conflict. But they're two very different emotions. So soft emotion, if you experience soft emotion, sometimes if you're feeling sad or hurt, you might increase your positive communication. You might do a little bit better job of expressing yourself in a constructive way that helps your partner understand what you're really thinking and feeling. Now, on the other hand, you might slightly increase your negative communication as well. So it's not entirely all positive, because if you're feeling sad, you might do a little better job of expressing yourself. But then on the other hand, you might also do some negative things. You might criticize your partner or say something that cuts your partner down or accuses your partner of something. So you might use some negative as well. Whereas hard emotion is associated with being assertive and maybe being threatening. When people express soft emotion, and this is a key thing about differences between these emotions, is that soft emotion expresses vulnerability. And if someone's expressing sadness or they're feeling hurt or disappointed, that person often appears to be expressing vulnerability to others. And soft emotion is often associated with relationship-focused goals. So whereas hard emotion, when you're feeling angry, you have some self-focused goal. I'm trying to accomplish something for myself, and that's getting blocked, and I feel angry about that. When people feel sad and hurt and discouraged, they often want companionship. They want someone else to listen. They want someone else to understand. They want someone else to give them comfort. They want to have a strong interpersonal relationship with someone else. And so when people feel soft emotion, they often have relationship-focused goals. And just to give us some contrast, when we're going through our output here, it'll help, this example will work well if we have three types of emotion to look at. And so I'm going to throw in a third type of emotion, which I'll call flat emotion, which is essentially maybe say in some ways a lack of emotion or a lack of aroused emotion. It's like feeling bored or apathetic or disengaged or disinterested. And in a relationship, if there's a conflict, there might be some times where if someone's feeling bored and apathetic, that might just be because the conflict isn't very important. Maybe if you're have a disagreement about, well, what movie should we see on Friday night? And one partner wants this, another partner wants that. If one partner says, well, I don't care, I'm bored, apathetic, it doesn't make a difference either way, then maybe it's just because that conflict isn't important. On the other hand, if it's a really important conflict, maybe you have a married couple and they're trying to decide whether or not to have a child, and one partner wants a child and the other doesn't, and one partner says, well, this is just, I don't care what you think, I don't care, I'm just bored with this. You can think whatever you want, but I'm not going to budge. In that case, it might be a negative thing. So flat emotion, if you're feeling bored and apathetic, you would probably not like to engage in conflict, so it might be associated with withdrawing from conflict. It might not really lead to positive or negative communication within the conflict itself, because you're not really engaging, so you're not really doing negative stuff, but you're not maybe doing positive either, so you're not really engaging in the conflict. I'm not sure we're going to find a whole lot of effects for flat emotion when we're looking at specific conflict episodes and how people communicate during conflict, but long-term wise, if someone's showing a lot of flat emotion during conflict, that could have a detrimental effect on a relationship long-term wise. So we're going to look at those three emotions. This is going to come from a study where people completed a questionnaire on the internet. We had 377 women, 266 men. These were people that were not married to each other, so they're individual people, but they were all in a marriage relationship with somebody. And we're going to look at their results from a conflict that occurred within the last 2 weeks. So everyone in the study reported that they had a conflict in their marriage within the last 2 weeks, and they're going to answer questions about what happened in that conflict. And our outcome variable, the thing we want to look at here, and we're going to look at the extent to which emotion is going to predict this outcome variable, and the outcome variable is positive communication. To what extent did you engage in positive communication? And examples here are like, I politely talked about my feelings. So positive communication is not a lack of communication. It's not to say, well, I avoided the conflict, or I didn't discuss it, or I said nothing was wrong. That would be more of withdrawing or disengaging or pretending nothing's wrong. But positive communication is, if there is a conflict, is a way of addressing and engaging in that conflict in the most constructive way possible. So like politely talking about your feelings and carefully listening so you can understand a partner would be types of positive communication. So the outcome variable we're looking at here is the extent to which people used positive communication, and they're going to self-report this. So they're going to think of a recent conflict that happened in the last 2 weeks. If they didn't, everyone in the sample had a conflict within the last 2 weeks. If they didn't, they weren't included. So think of a recent conflict, and then we had 7 items where they rated the extent to which they used positive communication during that conflict. And we had a good reliability, alpha 0.85, so that had good reliability. Now, what we're going to look at here, we can look at the effects of soft emotion and soft emotion, hard emotion in a few different ways. We can say, to what degree, if you're feeling soft emotion or hard emotion, how much do your emotions predict or correlate with how you behave? Or we could say, how much does your emotions predict what your partner does? Or how much, if you perceive emotion in your partner, how much does that correlate with what you do? And that's actually that third option. That's what we're going to look at here. So what I want to look at is, if you perceive soft emotion or hard emotion or flat emotion in a partner, does that correlate with the type of behavior you use? And our hypothesis is going to be that soft emotion actually is sometimes beneficial. And that if you look at your partner and think, my partner looks sad and hurt and concerned, that's likely to elicit more empathy and concern from you. You're going to feel more empathic and better able to engage in positive communication yourself. So our hypothesis is that although soft emotion is a type of negative emotion, it's something that people experience when they have a conflict in a relationship. And if someone's experiencing soft emotion, it's because there's a conflict going on. So on one hand, soft emotion can be a negative thing. But the hypothesis here is that soft emotion has a positive function, and that if I perceive soft emotion in my partner, I am going to be more likely to use positive communication myself. So I'm expecting soft emotion in a partner. If I perceive soft emotion in a partner, that I will increase my use of positive communication. Whereas hard emotion, I'm going to expect the opposite, that if I think my partner's angry and annoyed and irritated, then I might decrease my positive communication. So I have measures of partner soft emotion. It's actually a 4-item scale rated the extent to which in this particular conflict we identified. Did your partner appear sad? Did your partner appear hurt? Did your partner appear concerned? And did your partner appear disappointed? 4 items. We had adequate reliability, or alpha was 0.78. And then we also had a 4-item partner heart emotion scale, which actually is the same scale we've seen in several previous examples. Although previous examples we've had people rating their own emotion, this one they're rating their partner's emotion. Did your partner appear angry, annoyed, irritated, or aggravated? 4 items summed together are alpha 0.83. We had good reliability for our partner heart emotion scale. And then we also have this flat emotion. I don't have a whole lot of hypotheses here, but we will put it in the analysis to make it interesting. It works well to have 3 predictors for this example. So I'll put flat emotion in. Measure the extent to which you thought your partner appeared bored, uninterested, indifferent, or disengaged. Those 4 items were summed together to create a scale. It had good reliability, alpha 0.88. So those are our 3 predictors. We have 3 predictors: hard emotion, soft emotion, flat emotion. Our outcome variable is the extent to which you reported using positive communication, or the respondent reported using positive communication in this conflict. Now, one of the issues in this study is an issue with monomethod bias. Because if I find a correlation, if I find, for example, that soft emotions correlated with positive communication, or that hard emotions correlated negatively, inversely, with positive communication, if I find correlations, one of the things I don't know, do I find correlations because soft emotion actually indeed correlates with positive communication, or is this something I might call a monomethod bias, where I'm assessing everything via self-report? So I'm assessing your emotion, how much, or your perceived partner emotion with self-report, and I'm assessing your reported communication with self-report. The same person's reporting, here's what I saw in my partner, here's what I did. So everything's coming from the single person's writing on the questionnaire about what they saw in their partner and what they did. So what if someone comes into a study and says, well, I am an optimistic, happy person. Did your partner look angry? No, I'm happy and optimistic about everything. My partner was not angry. Was your partner showing soft emotion? Yeah, I'm kind of soft or gentle. Yeah, soft emotion, that's what I saw. Did you use positive communication? Oh, yes, I used positive communication. And a person could be giving those responses not because that's really what happened, but more because that's just their response bias when they complete questionnaires. If the same person is completing all the questionnaires, and if they have an optimistic, positive response bias, then there's going to be positive correlations between things, because the optimistic people will give positive responses to everything, and then the pessimistic people will give negative responses to everything. Happy people give positive responses, negative people give negative responses, and that'll create correlations between my variables, not because the specific variables are related, but just because people have response biases when they complete questionnaires. So that is a major problem with this study design, is that if I get correlations, I don't know what's really driving those correlations. Is it because the emotion really is related to the communication? Or am I just tapping a general response bias that people have when they complete questionnaires? So what can I do about this? Well, one option is I can try to control for that response bias. What I can do is I can create some variables that are things that are going to tap into a person's response bias, and put those variables into my analysis and control for those variables to see if there's still a relationship between emotion and communication, after controlling for these other variables that are going to tap into response bias. And so I have some variables here that are actually going to be very specific to the type of response bias we might get in the study, which is a response bias pertaining to talking about communication in your romantic relationship or in a marriage relationship. So I have two questionnaires here. One is called the Communication Patterns Questionnaire. And this is a questionnaire measuring, just in general, to what extent would you say you use negative communication in your relationship. So in our previous questions, back here we're measuring partner soft emotion, hard emotion, positive communication. All of these variables, people are, we'd say, event specific. These are all questions about their emotion and their communication in a particular conflict that they identify that occurred within the last 2 weeks. But the Communication Patterns Questionnaire this is in general. It's not about a specific conflict. So this is going to measure your general tendency to say, we use good communication in our relationship, or we don't use good communication. So it's in general in your relationship. Do you tend to use negative types of communication? There's 7 questions on this. Had good reliability, and a high score means you're reporting in general we have more levels of relationship conflict. Something called the Communication Patterns Questionnaire. So it's measuring your tendency to report having lots of conflict in your relationship. And what I'm expecting is that we'll still find a relationship between emotion and communication in specific episodes of conflict, even after controlling for your general tendency to say we have a lot of conflict in a relationship, or we don't have a lot of conflict, we don't have conflict. And then the other overall questionnaire I'm going to use is another measure of relationship satisfaction. Last example, we looked at something called the Data Adjustment Scale. This is another classic measure of satisfaction called the Quality Marriage Index, or QMI. It's just another measure of overall how happy or satisfied are you in your relationship. It has 7 items, and it has adequate reliability. The alpha is 0.78. So what we're going to do is we're going to do a 2-step regression analysis. Step 1, we're going to enter these 2 variables as our control variables, the Communication Patterns Questionnaire, or relationship conflict, and relationship satisfaction. And these are going to give the extent to which to give us a relationship between global appraisals about your relationship or your response bias. How do you fill out questionnaires about your relationship in general and about conflict in your relationship? What's the correlation between your general relationship traits that you report and your positive communication in this particular conflict? And there's probably going to be a fairly strong relationship there. And what I want to see is, even after controlling for that, is there still a relationship between emotions and positive communication? So we're going to enter one block. Step 1 will be these 2 variables, Communication Pattern Questionnaire, Quality Marriage Index. Those are going to go into step 1. Step 2, we're going to enter the 3 emotion variables to predict the outcome, which is self-reported positive communication. So let's look at result. Here are results for husbands. So now we've got our outcome variable is going to be called POS. That stands for positive communication. Our 2 block 1 control variables, CPQ, that's the Communication Pattern Questionnaire, and QMI is the Quality Marriage Index. So CPQ, that's the measure of relationship conflict, the general measure of relationship conflict. QMI, that's a measure of relationship satisfaction. And then we have our 3 emotion variables. P hard stands for partner hard emotion. P soft stands for partner soft emotion. And P flat is partner flat emotion. And so here are the mean standard deviations for all of our variables for husbands. Altogether, we have 266 husbands in our sample. Let's go down our output, see what else we have. Now we have correlations. Recall correlations, that's going to give us the effect of each predictor, predicting variance or explaining variance, correlating with the outcome, ignoring the other variables in the equation. So CPQ, that's the general measure of conflict that has a negative correlation with positive communication, and that is significant. QMI, which by the way, the negative correlation, so we're saying that if CPQ is measuring reports of relationship conflict, so as conflict goes up, positive communication goes down, that makes sense. QMI, it's a positive correlation, say as your relationship satisfaction goes up, positive communication goes up. Small correlation, but it is significant. We have a fairly large sample here that gives us power to detect effects even when we have small correlations. Hard emotion, feeling angry, we have a negative correlation there. When you're when you perceive hard emotion in a partner, that correlates with reporting less use of positive communication yourself. Soft emotion, now this is going in the expected direction. That's a positive correlation, saying if you perceive soft emotion in a partner, that's correlated with increased reports of using positive communication yourself. And that's actually crosses the threshold to call that a medium-sized correlation, and that is significant. And actually flat emotion is negatively correlated. That actually turned out to be significant as well, that if you think your partner looked bored and sad and disinterested, you are less likely to report using positive communication. So it turned out that actually all 5 of those variables had significant correlations with positive communication. Let's keep on scrolling down our output, see what else we find here. Now at this point, our output looks a little bit different than our previous examples with regression, and that's because we have two steps here. So with our previous example, we just entered everything in one block or one step, or we entered everything simultaneously. So if I had 3 predictors, I just put them in all at once. But now in this example, we have multiple steps. We have step 1 and step 2, or block 1, block 2. We're going to put one set of variables in at step 1, and a second set of variables in are going to be added at step 2. And we can call that, one way to refer to that, we could call that our constrained model. Step 1 is going to have just those 2 variables measuring your overall responses in your relationship, satisfaction and levels of conflict. And then step 2 is going to include we'll add the additional 3 emotion variables to have 5 altogether. So we can call step 1 will be our constrained model, where it only includes a subset of the variables. Step 2 will be our full model that includes all 5 variables. So we have step 1, step 2, or we can call that model 1, model 2, which is actually the language used in our output. So we have, which is model summary. Recall from before, we had an R squared, was reported up here, but now we have R squared for model 1 and R squared for model 2. So that says in model 1, where I put just, and if you're ever confused about what variables were used, down here at the bottom says A, this is for model A, or model 1. The predictors were the QMI and CPQ. B, for model 2, predictors were QMI, CPQ, plus soft emotion, hard emotion, and flat emotion. So if you ever get confused about what is what in your models, you can look at those footnotes and see what it is. So model 1, where I had just 2 predictors, we explained 9% of the variance. Model 2, when we added 3 variables to have a total of 5 predictors, we explained 19% of the variance. So we have the R squared for model 1 and the R squared for model 2. Are those R squared significant? We can look down here at our ANOVA table, and again, we have an ANOVA table for model 1 and an ANOVA table for model 2. For model 1, with just 2 predictors, our F value is 13.57, and that is significant. And model 2, with all 5 predictors, our F value is 12.22, and that is significant as well. So both those R squareds are significant. 0.09 and 0.19, both of those R squareds are significant. Now we also have change statistics. This is one thing, if you enter everything in one block, you don't have this, but the key advantage of doing things in 2 blocks like this is, in fact, the main reason why I would do this is because I want to know, going from block 1 to block 2, how much additional variance was explained. That is, how much did I explain just by response bias alone? If those first 2 variables, the QMI, your overall satisfaction, your overall report of conflict, my thought is that those are tapping your general response bias and describing your relationship. So those 2 variables talking about one's response bias, how much variance in your self-reported positive communication is explained just by that response bias alone. And we'll get that from block 1. That's what we got here, 9%. And the key question is, going from step 1 to step 2, how much additional variance was explained when we added those emotion variables to our equation? How much additional variance was explained by those 3 emotions taken together? And going from block 1 to block 2, 0.09 to 0.19, we can see by subtraction, 0.19 minus 0.09 gives us 10%. We've explained an additional 10%. And our output shows us that over here, where it says change statistics, this side over here, this is a thing we did not see. This block is a new thing. We haven't seen that in previous analyses. This is giving us change statistics. It's saying how much additional variance was explained going from one block to the next. Now, SPSS does something that's kind of odd here. I don't know exactly what the purpose is or who decided to do it this way. But they start off, they give you the change statistics for model 1. This first row here, it says 0.09. This first row, that's the change statistics for model 1. In other words, what that's telling you is, well, the previous model was nothing. So how much did model 1 increase over and above 0? Which that's kind of a silly thing to ask. So we're saying this R squared 0.09. How much larger than 0 is that? Well, 0.09. Okay, we'll put that right here. 0.09. Over here, we got an F value, 13.57. How much bigger than 0 is that? Well, 13.57. So that first row where it says change statistics, that's just redundant with the information for Model 1. I don't know why they put that in analysis, but they did. It's just redundant with other stuff, so we can just ignore that. The key thing we really want to know is the change statistics for Model 2. So for Model 2, change statistics, right here, this R-squared change, that tells us how much did Model 2 increase over and above Model 1. And we just saw that. We take 0.19, that's what we had in Model 2, minus 0.09, and we see that gives us, we've increased by 10%. We've explained an additional 10% of the variance when we added our 3 emotion variables. And if I want to test the significance of that R-squared change, I test the significance of an R-squared change with an F change, or delta F. The symbol delta stands for change, so we can call R-squared change, we can call that delta R-squared, and F change, we can call that delta F. And the delta F, right here, 10.36 degrees of freedom, 3 degrees of freedom numerator, 260 degrees of freedom denominator, and the probability of that F value, if the null hypothesis were true, is something less than 0.001, or it rounds to 0.000. So we have 3 types of omnibus effects we can look at in this page right here we're looking at. We can look at what are the effects of, what's the total effects explained at step 1, 9%, and our F value is right there. What are the total effects explained at step 2, 19%, and the F value is down here, 12.22. And what is the additional variance that was explained going from Model 1 to Model 2? It explained an additional 10%, and the F change is right there, 10.36. So we can address all 3 of those questions with this output on this page. And let's keep scrolling down. Very bottom of this output, we have our beta weights. And once again, we have beta weights for Model 1 and beta weights for Model 2. So for Model 1, we had just 2 predictors, CPQ and QMI. And our beta weights are right here, negative 0.17 and negative 0.03. Here are the standardized beta weights. And we can look and see that actually, as it turned out, when we put these 2 together, the communication pattern questionnaire, that's the measure of conflict communication, the extent to which you say we have a lot of conflict in our relationship, that was significantly related to your positive communication, beta weight negative 0.34, saying that when we have a lot of negative conflict, that our positive communication goes down. And that is significant after controlling for satisfaction, but satisfaction, QMI, was not significant. Our p-value is not less than 0.05 there. So that became not significant after controlling for conflict. Then we have Model 2, which includes all 5 predictors. So it includes the same 2 we started with, CPQ and QMI, our overall relationship conflict, overall relationship satisfaction, and it also includes the 3 emotion variables, hard emotion, soft emotion, and flat emotion. And we can see over here that actually, although all these variables had significant correlations, hard emotion, that p-value is not significant, and flat emotion is not significant. So both hard emotion and flat emotion became non-significant after controlling for the other variables in the analysis, including after controlling for the general response bias variables measuring how happy you were in the relationship and how much you tended to report having conflict in your relationship. But importantly, soft emotion, that is, our beta weight is 0.3. We've got a moderate beta weight there, a standardized beta weight. And our p-value is definitely less than 0.05. Again, it's rounding to 0.000. So we have a significant beta that we're showing that we are explaining that soft emotion does explain unique variance in one's own use of positive communication. And it does so even after controlling for everything else in this equation. Okay, what are some things that I might ask you to do with this output? Well, one thing is I might ask you to calculate this delta F. Our delta F is 10.36. I could scribble that out and say, you calculate that delta F, the F change. So how would you do that? Well, to do that, you need this, this table. This is our delta F calculation table. And we need to fill it in. So we need to calculate the sums of squares regression or explained variance. And to do that, so first we need to calculate right here, sum of squares explained variance, or sum of squares regression. And what it is, you want to calculate, get the sum of squares full minus sum of squares constrained. And those are values that will come from the ANOVA table. So down at the bottom, I have, this is the ANOVA table from our two-step regression output. And this is where we have the ANOVA table for model 1, which is the two predictors. We'll call that our constrained model. The constrained model is a model that doesn't include all your predictors. Model 2 is the full predictor, it includes all 5 predictors. And so to get up here in our delta F table, we need to calculate the sum of squares regression, or the sum of squares for explained variance. And we do that by taking the sum of squares for our full model, for our explained variance, which is 28.33, minus the sum of squares for our constrained model, 13.93. So that goes right there. And 28.33 goes there. 28.33 minus 13.93, I get 14.4. So that is our sum of squares explained variance, or sum of squares regression. Now we need to calculate our degrees of freedom for our regression, or degrees of freedom for explained variance. And again, we'll take our full model degrees of freedom minus constrained. Our full model degrees of freedom was 5. Let's put that right there. Constrained model degrees of freedom was 2. Put that right there. 5 minus 2 gets 3. Which, by the way, note that your degrees of freedom for your explained variance in a delta F will also be simply the number of predictors that were added at that step. Step 1 had 2 variables. Step 2, we added 3 variables to get 5 variables altogether. 5 minus 2 gives us 3. In other words, we added 3 variables, so our degrees of freedom are 3, because that's how many additional variables we added to our model at step 2. And now we can calculate our mean square for our explained variance, or mean square regression, by taking our sums of squares divided by degrees of freedom, 3, to get our mean square regression, which is 4.8. And so I plug that in. So now I've done everything for my explained variance, my regression. It's sums of squares, degrees of freedom, mean square. I've calculated all that. I'm ready to calculate things for the error variance, error sums of squares. And actually, this is really easy because everything for the error sums of squares is just identical to what we have down here for our error sums of squares for our ANOVA table for model 2, that is our full model with all the predictors. So we had 120 was our sums of squares for our full model. That goes right here. We had 260 degrees of freedom. That goes right here. And our mean square then was 0.46, so that goes right there. We just plug everything in. And so we have 120.55, our sums of squares, 260 degrees of freedom, and then take our sums of squares divided by degrees of freedom and get our mean square. And again, that's just taken directly off the ANOVA table for the Model 2 error sums of squares line. And now we're ready to calculate our delta F. We take our mean square explained variance divided by mean square error. That's 4.8 divided by 0.46, and I get 10.435 is our delta F. Now note, we actually got a slightly different delta F down here. It was 10.36 is what our SPSS output showed. And again, this is one of those situations where we're dealing with rounded variables, and so we got something that's just slightly different from the actual output. And of course, if this were homework or test, and I had scribbled this out and asked you to calculate it, then you'd give me the value that matches the numbers you worked with, and the right answer would be 10.435. So that is how you would calculate the delta F. Let's go through the 5 pieces of information of how you would address questions of effect size and inferential statistic in a multiple step regression. And we have a few additional questions that we can address with a multiple step regression that we didn't have when we had just a single step regression. Although some of these are the same. The first thing I have here, this is the same question that we looked at before. What is the standardized association between x3 and y without controlling for the other variables? What is the name of the descriptive statistic for an effect size? What is the value for that effect size? What is the name of an inferential statistic you can use to test the significance of that effect size? What is the value for your inferential statistic? And what is the p-value? What's the probability of the inferential statistic if the null hypothesis were true? And so in this case, the standardized association between x3 and y without controlling for other variables. This is the same question we looked at in our previous example. We addressed that with what is the effect size? It is a correlation. And if I'm asking about x3 here, so this is 1, 2, 3, I'm looking at the association between partner heart emotion and positive communication. So our correlation is negative 0.14. And then how would you test the significance of that? Well, you'd calculate the t-value, and we've done that before. You have to calculate that because it's not given to you in the output, so you would calculate the t-value, and that would be your inferential statistic is a t-value, and then the p-value, the probability of the t-value if the null hypothesis were true, in this case is 0.009. And if I ask you to give me exactly as it's printed in the output, you'd write period 009. And another thing that we can ask, and this is again similar to our previous example, what is the standardized association between x3 and y after controlling for the other variables in the equation? And this is just like our previous example. The effect size, the descriptive statistic for an effect size here will be a standardized beta. And so if I'm looking at the association between x3 and y, our standardized beta for x3, this is 1, 2, 3, is heart emotion, partner heart emotion. Our standardized beta is 0.07. And our inferential statistic is the t. And our value for the t is negative 1.13. And our p-value, which is not significant, is 0.259. And if I ask for that exactly as printed, then give me 0.259. Don't round to 0.26, but give me 0.259. Okay, now is the point where we get to some additional questions that we couldn't get to with our previous example where we had just a single step where everything was entered in one block. But now where we're entering things in multiple blocks, we can address these additional questions. So, what is the percent of variance in y explained when just the first set of predictors? Which, by the way, all these I have 3 questions that we're looking at on this page, and all 3 of these questions are going to ask about percent of variance explained, and the answer to all these questions are going to be an r squared. But it's a matter of which r squared are we talking about. So for the effect size, percent of variance explained when just the first set of predictors are entered in step 1, that's asking about the r squared from model 1. So our effect size is r squared, which is 0.09. How do we test the significance of that? We do that with an F test. So F is the name of the inferential statistic, and the value is 13.57, and the p-value is 0.000. So that first question, the percent of variance in y, explained when the first set of variables was entered in step 1, our effect size, name r squared, value 0.09, name of inferential statistic, F, value 13.57, and p-value 0.000. Okay, let's look at the next question on this page. Additional variance. What is the additional variance in y that was explained when the second set of variables were added to the equation in step 2? So this is looking at how much additional variance was explained. That's looking at the r squared change. So the name of our effect size here, and this is an r squared, but I want to be clear, it's the delta r squared, or r squared change. So r squared change, or delta r squared, that is our effect size, and our value was 0.10, or 10%. And how do we test the significance of our delta r squared, of our r squared change? With a delta f, or an f change value. So f change is our inferential statistic. And with this, for the r squared, make sure you say delta r squared or r squared change, either way, but one way or another, clarify that you're talking about the delta r squared, or the r squared change. And the same thing for f. Clarify that you're talking about the delta f, or f change, whenever you report the names of these statistics. And our p-value for that is again 0.000. And then the third question, what is the percent of variance explained by all the predictors taken together? In this case, we've got 5 predictors. What is the percent of variance explained by all 5? That's looking for R squared in model 2. In our full model, we've explained 19% of the variance using all 5 predictors taken together. And how do we test the significance of that? We test the significance with an F test. So F is the inferential statistic, and our value is 12.22, and the p-value is 0.000. Okay, so that is all the types of questions that I might ask about for doing a multiple step regression. And we have one more thing to go over, which is how would you give a written summary of a multiple regression? And for that, let's look at the output for wives. We've been talking about the output for husbands. Let's switch over and look at wives and see what happened with the people who were women in this particular study. Again, here's our descriptive statistics. Showing we have the 5 variables, our outcome variable, self-reported positive communication, our 2 variables measuring your response bias, or that extent to which you have this mono-method response bias, CPQ, measure of relation of conflict, QMI, measure relation of satisfaction, and then the 3 variables measuring perceptions of partner emotion, partner hard emotion, partner soft emotion, and partner flat emotion. Cut. Okay, and then scrolling down, here are our correlations. And these correlations are almost identical to what we saw for husbands. The one slight difference is that actually for wives, that partner flat emotion, for husbands, that correlation was small but significant. For wives, we have a correlation that's small and actually not significant. But otherwise, all these correlations are significant. They're in the same direction as what we saw for husbands. And our soft emotion, as we saw before, it's positively correlated. That wives are saying, when I see sadness and concern and disappointment in my partner, I tend to use more positive communication. So we have a positive correlation between perceived partner soft emotion and positive communication. Let's scroll down and see what else we find. So our total, our R squared, 0.08. For model 1, when we enter just the first 2 variables were entered into analysis, we explain 8% of the variance. We add the other 3 variables for all 5 together. We explain 14% of the variance. Our F values for part 1, F was 17.22. That was significant. And when we added all 5 all together, we had 11.6, and that is significant. So just like husbands, model 1 was significant with 2 predictors. Model 2, our full model, was significant with all 5 predictors. What about the R squared change? What was the difference? 4.14 minus 0.08. And this is a situation where rounding makes this look a bit odd, but if we carried it out enough decimal places, we would see that actually this comes out exactly right. But the difference between the two, with rounding, it shows us as a 5% increase in explained variance going from model 1 to model 2. Although, as you can see, that we're rounding, so that wouldn't 0.14 minus 0.08 does not exactly give us 0.05, but if we carried it out enough decimal places, it would come out right. And then here are our beta weights for wives. Same basic pattern. The CPQ was significant. That's the measure of your general response bias for saying we have conflict in our relationship. And partner soft emotion, beta weight 0.22, and it was significant as well. So essentially, the output for wives in this case is almost identical to the output for husbands, not a whole lot of difference. Okay, so the whole point here is, for looking at this, I want to go over how would you give me a written summary of the results for wives. And for a two-step regression equation, the process of giving a written summary is going to be very, very similar to how you would give a summary for just a single step. But there are several subtle differences that would make it such that you want to be very clear about what you're doing, because if you try to do the wrong thing in the wrong place, it's going to make a big mess of everything. So first thing, make sure you're really clear. Am I reporting results from just a single step regression, or am I reporting results from a multiple step regression where I have 2 steps, say, and I have a block of variables at step 1 and entering another set of variables at step 2? So if you have 2 steps, how do we report that? And what I have here is actually the first of 2 paragraphs that I'm going to show you. And the key thing that I'm going to be doing here is I'll have one paragraph summarizing the effects for step 1, and a second paragraph summarizing results at step 2. And I suppose that's the key thing, because if you just give me one paragraph, you're going to miss all the stuff you need for 2 paragraphs, and you would get almost 0 points because you missed all the stuff you need to do for the 2 paragraphs. And if you tried to give me 2 paragraphs when you had just a single step, that wouldn't make any sense at all. So it's important to make sure you give me the right type of summary for the type of analysis you're doing. Aside from that, though, you will notice there's a whole lot of similarities between how to give a written summary for a single step and for multiple steps. So let's see, as before, I have an initial sentence that tells the reader we're doing a regression analysis, and I name the outcome variable, Y's positive communication, and I name the predictors. It was predicted using their reported level of relationship conflict and their overall satisfaction. So that's almost identical to the same first sentence I gave you before. A couple things to keep in mind. One key thing is that here I have the phrase the first step, and that's an important thing to put in there, because when I say in the first step, that cues the reader into the fact that we're going to do multiple steps here. So one important difference, make sure you don't just say in a regression analysis, but say in the first step, because this paragraph is only going to be talking about that first step. Another thing to make sure you do here is make sure that you only talk about the variables that were entered at the first step. So this analysis, we used 5 variables altogether, but don't talk about the partner emotion variables, because that's a later step. We're not doing those here. So only talk about the variables you put in at step 1. So step 1 was only Y's positive communication was predicted using their relation of conflict and relationship satisfaction. Those were the only 2 variables were entered at step 1. Make sure you only talk about those 2 variables. Then we're going to do the same thing we did before, where we're going to talk about the omnibus effect at step 1. What was the total percent of variance explained? So the 2 predictors explain a significant portion of variance in positive communication. That's giving that omnibus effect at step 1. And I'm going to give the 5 pieces of information, just as we did before, where I give the R squared. Now, one thing to be clear about here, you want to make sure you do the R squared for step 1, talking about the percent of variance explained at step 1. We explained 8% of the variance, everything rounded to 2 decimal places. Give the F value for step 1, degrees of freedom in parentheses. Our F value was 17.22. And then because my P value was smaller than 0.001, it rounded to 0.000, but I never type P is equal to 0. So I say P is less than 0.001. And so this sentence right here, the 2 predictors explain a significant portion of variance in positive communication with my 5 pieces of information. That is the same format we looked at in our previous example with just a single step. Now, here's a point where things are going to get just a little bit different, because in our previous example, I had you create this table and give me the results for your beta weights and correlations. And we're going to do that here, but we're going to wait. We're going to wait and do that for step 2, because if I gave you a table for step 1 and then another table for step 2, that starts to be too much. You're going to overwhelm the reader with a lot of information that the reader really doesn't need, because really the key thing we're doing with these variables at step 1 is these are control variables we're trying to control for people's response bias, and we're not that interested in the results here. And if I start giving the reader all kinds of stuff that's trivial and irrelevant, it just gets too much to sort through. So I'm not going to do a table for step 1. I'll do a table for step 2, but not for step 1. So for when you're giving the summary of step 1, do not put a table in there. Save that for step 2. So although I'm not putting a table, I will go ahead and summarize what was in that table if I had a table. So the same thing, we had a small negative correlation between conflict and positive communication. and conflict explain unique variance in positive communication after controlling for satisfaction. So that's that same template we looked at before for what do you write if there is you have a significant correlation and a significant beta weight. And then another thing, we have another sentence down here. This is what to do if you have a significant correlation, but the beta weight became non-significant. Although there was a small positive correlation between satisfaction and positive communication, the effect became non-significant after controlling for conflict. So those are the same two ways we summarize the output that we talked about in the previous example. We have one situation where we had a significant correlation and a significant beta, and another situation where the correlation was significant, but the beta was not. And we're just following that same basic template here. Note that in this example, we did not have any scenario where the correlation was not significant. So I don't say anywhere that I don't have that phrase that says, notably, the effects for this variable were non-significant, or notably, this variable is not related to this outcome. I don't say anything like that because that doesn't fit with what's going on in this example. Okay, so that's step one. So it's basically the exact same template that I gave you for a regression, which is a single step, except for we have this word first step here. I'm only talking about the first step, and I have omitted the table. Otherwise, it's the same paragraph. Now let's go on to the paragraph for step two. And this I start by saying in the second step, so now I'm telling the reader we're going on to the second step, and we've already told the reader what the variables were at step one. The reader already knows what the outcome variable is. The reader already knows what two variables were entered at step one. So we don't need to repeat all that. At this point, we can just say, what were the additional variables that were added to the equation at step two? So I'm just going to say that. Ratings of partner soft emotion, partner hard emotion, and partner flat emotion were added to the equation. So I'm just telling the reader what were the additional variables that were added to the equation. And then I'm going to go on and summarize, as we've done before. I'll summarize the omnibus effect for step two. Now, we have a couple different things we could look at here. We could say, what is the total variance explained at step two with all 5 predictors? Or what is the additional variance that was explained when I added the 3 predictors, that R-squared change? And in this analysis, that is the key question we really want to know. That's the thing we're really most curious about. What is the additional variance explained when I added those 3 additional emotion variables to our model? So I'm going to focus on that. So for the omnibus effect here, I'm going to talk about that R-squared change. The 3 variables explained a significant portion of additional variance. And that word additional is key. It's another thing. I don't know how you could describe what we're talking about without using the word additional, because we're talking about how much additional variance was explained over and above that first model. So we're talking about the additional variance explained, and you need to have the word additional in that sentence. What was our additional variance explained? Now we're going to give the 5 pieces of information. Our R-squared is our delta R-squared. You could use the triangle delta symbol, or you could write out delta. Either way is fine. But make sure you clarify we're talking about delta R-squared, and don't just say R-squared. Do clarify it's delta R-squared, or R-squared change. Our delta R-squared was, with everything rounded to 2 decimal places, is 0.05. We've explained 5% of additional variance. Our delta F, and again, clarify delta F. Don't just say F, say delta F, or use a triangle symbol, or say F change. Delta F, with degrees of freedom in parentheses, is 7.28. And our p-value is p is less than 0.001. So that is summarizing the results for that delta R squared, the additional variance explained. Now at this point, go ahead and also mention, we haven't talked about what are the effects of all the variables taken together. Go ahead and mention that. And here, I've just done that really brief. I just said, and all 5 variables taken together explain 14% of the variance. And I did not give all 5 pieces of information. That is, I didn't give the F value and the P value for that. You can do that either way. It doesn't. If you want to, you can do it just like I have it right here, where you just say, what is the percent of variance explained by all the variables taken together? Or if it's easier to remember, and it would be easier just to go ahead and give the 5 pieces of information and give me the, say, the R squared, and the value of the r-squared, and also give me the f value and the p value for that. If that's easier, do it that way too. Either way is fine. So the important thing, we do want to make sure we have all the information for the r-squared change, for the additional variance explained. But for the question of what was the total variance explained at step 2, you can abbreviate that if you want to, and just tell me what the percent was without giving me the f value. So either way on that. So now at this point, we can do what we did before, where you write a table that summarizes results. This is the point where I want you to put that table. So we want to make a table. We want to refer the reader to the table and give a summary of that table. So I've got the next sentence. It says correlations and standardized betas are reported in table. This time I call it table 3. So we're going to make a table, put everything in there. Let's go look at that table. Here is how that table looks. So note what I'm doing here is that I'm going to give you the table for our second model, for model 2 with all 5 predictors. I'm just going to report that output. I'm not going to report a table for model 1 with just a constrained set of predictors. Otherwise, it's the same table. So I've got a title at the top. I've got 3 horizontal lines. I've got no vertical lines. I've got 1 column for correlations, 1 column for standardized betas. I have all 5 predictors here, so I've got my 2 variables that were entered at step 1 and the 3 that were entered at step 2. I've got their correlations. I'm using asterisks to indicate what's significant. And then I have the betas. And note that these are all the betas from step 2, or the model 2, from the second block with all 5. I'm not using the betas from step 1. I'm only reporting the betas from model 2 with all 5 predictors in it. And as we saw here, the beta weight for relationship conflict was significant, and the beta weight for partner soft emotion was significant. So that's what our table looks like. Now we're ready to go back to our text and give a written summary of what's going on in this table. Now here's one more thing that's to keep in mind about one of the things when doing a multiple step regression and reporting results. When you're doing the second paragraph and talking about model 2, don't summarize results for the variables from step 1. You've already talked about step 1 in our previous paragraph. If I back up a page here, this was our very first paragraph. You've already talked about a summary in this step of the variables at step 1. And if you talked about these variables again, that's going to be too much, because again, we're not that interested in these variables. These variables, they're just control variables, and we don't care that much about these variables. And if we talk about them too much, it's going to be overwhelming and just trivial. So we've already talked about these 2 variables. In this case, the overall negative communication variable and the relationship satisfaction variable. Those 2 variables, those 2 predictors were already talked about in this paragraph. So going to our second paragraph, don't talk about them there. If the reader wants to look at the table and see exactly what was significant and what wasn't, the reader can still do that because you've given that information in the table, but there's no need to talk about it in the paragraph. So I'm only going to summarize the results from the table, the standardized betas and the correlations. I'm only going to summarize that for the variables that were added at step 2 for our emotion variables in this second paragraph. So we had one situation where we had a significant beta and a significant correlation. There was a small positive correlation between partner soft emotion and positive communication. And again, we're talking about, we give the direction and the size. It was a small correlation. It was a positive correlation. And I named the 2 variables between partner soft emotion and positive communication. So that summarizes the correlation. And then I say, and soft emotion explained unique variance in communication after controlling for the effects of the other variables in the equation. So that's that same template to use when you have both a significant correlation and a significant beta. Then we have, next we have, although there was a small negative correlation between partner hard emotion and positive communication, this effect became non-significant after controlling for the other variables. So that's the situation where we had a significant correlation and a non-significant beta. And again, with a correlation, we've given the size, it's small. We've given the direction, it's negative. And by the fact we mention it, it implies that it's significant. And then we say that this effect became non-significant after controlling for the other variables because the beta weight was not significant in step 2. And in this case, flat emotion for wives, for husbands, actually, we would have said something different for husbands, because for husbands, flat emotion actually had a significant correlation. But for wives, which we're summarizing here, that correlation was not significant, and the beta weight was not significant. So I say, notably, partner flat emotion was not significantly related to positive communication. And again, there's our table. And that is everything